Imagine we take a fair coin and we flip it 20 times, and on 18 of those times, it comes up heads. How unusual is this? Is it not at all? A little bit, a lot, a whole lot? I think most people would say that getting 18 heads out of 20 flips is very unlikely. And a p-value is just a number that answers this question. If the coin really were fair, how unlikely is a result like this? So getting 18 heads out of 20 would be very unlikely if the coin was fair. So our p-value is going to be very small. At this level, we can just think of the p-value as measuring how surprising a result is, given that the coin is fair. So the p-value isn't just the chance of getting 18 heads, it's getting 18, 19, or 20 heads. And why is that? Well, getting 19 heads or 20 heads is more extreme than 18, and anything 18 or more is going to be classed as unusual in this example. So when we calculate a p-value, we always ask, what's the probability of getting this result, or something more extreme, assuming the coin is fair? Let's say we were looking at it in the other direction and we got 2 heads, then getting 2 heads or 1 heads or no heads would be deemed as our more extreme example. So extreme or more just means that the results that disagree with our assumption at least as much as the one we saw. So everything we've looked at so far relies on one key assumption, and that is that the coin is fair. And we give this assumption a special name and we call it the null hypothesis, or H0. So the null hypothesis is our starting point. We assume that it's fair, and then given that assumption, we look at our data and see how that fits with the null hypothesis. After we collect the data, we ask, how likely would this result be if the null hypothesis were true? So if the p-value is small, it means that the result is very unlikely, given that the null hypothesis is true. And in that case, we say the data doesn't sit well with the assumption, so we reject that initial assumption. We reject the null hypothesis. If the p-value is large, we say that it fits well with the data, and in that case, we fail to reject the null hypothesis. We keep our initial assumption. So under the hood, it's all about probability distributions, and different processes have different distributions. So say, for instance, flipping a coin, that follows something called a binomial distribution. Rolling a dice follows a uniform distribution, and so on. Different processes have different distributions, or basically different patterns of how we expect the data to fall. So when we calculate a p-value, we're placing our observed result inside the distribution implied by the null hypothesis and asking, how far out in the tail is this result? So the p-value is literally the tail probability of getting a result as extreme as what we did under the null assumption. So formally, a p-value is the probability of observing a result at least as extreme as what we did, assuming that the null hypothesis is true. It does not tell us the probability the null hypothesis is true, and it doesn't predict what will happen next. It just tells us how incompatible the data is with our model. So a p-value isn't about belief or certainty, it's about surprise under a specific model, or how surprised we are that something came up, given that we expected something else to come up. So in a 5-second summary, a p-value is just the probability of getting the result that we did, assuming that the null hypothesis is true. So the smaller the p-value, the more surprised and the more likely we are to reject the null. The bigger the p-value, the less surprise we have, and the more likely we are to keep our assumption. We then have some cutoff point because we like thinking in terms of black and white. So we have some cutoff point in which we say that this result is unusual or this result is not unusual, and that is called our significance level, which by default is 5%. And we say that if something is less than this significance level, we reject the null. If it's greater than this significance level, we keep the null. And that significance level is just our line in the sand that separates unusual from usual. Of course, that 5% is really just arbitrary. Sometimes it could be 1%, sometimes it could be 10% by default, but it doesn't always mean that if we get something smaller than that, it is definitely different from the null. It just means that it's very unlikely to have come from that same distribution with the same assumptions that the null had.